The questions was given to us by Valentine Machejo, and I'm going to look at the first question I want to look at is the following one. They say, simplify each of these without the use of a calculator. The first one is the cosine of x plus 65 degrees, then the cosine of x plus 20 degrees, which is minused from the sine of the product of sine x plus 245 degrees and multiplied by the sine of x plus 20 degrees. Now, folks, remember you have your compound angle formulas, but what should tell you that you're not going to expand this is the following, is the fact that you've got cos, cos, sine, sine. Cos A, cos B minus sine A, sine B is going to become the cosine. It's cos, cos, sine, sine, so it's a pattern cosine A plus B. So as long as we can get this angle and that angle the same, these two are already the same. So we need to fix those two over there. Okay, so how do we do this? We're going to start off and we're going to say we don't want to change. These angles are going to stay because they are acute angles in terms of the angle 65. So cos, we don't know what x is, but this is acute, plus 20, minus the sine. Now look at this. If we have, let me write it in white here, 245 degrees. 245 degrees is the same as 180 plus 65 degrees. Okay? So if I have this angle here, I can change this 245 to an angle that is 65 to get my two angles to look exactly the same. Okay, so what do I have? I have the sine of x plus 245, which must become the sine of x plus 65. Okay, folks, now remember, if I'm working with this angle over here, that angle is a complete angle where there's already an x. So I've got x plus that, and I have x plus the 180 plus 65. So if I take the sine of this, and I take the sine of this side over here, it's 180 plus x, x plus 180 is simply just the sine, the minus the sine of x by itself. If I do my reduction formula, if I apply my reduction formula over here. So having done that, I end up with my sine of x plus 65 degrees, which is exactly what I wanted to do with this first compound angle that I had over there. Okay, so multiplied, I do not want to change the back part. I want to leave it as the sine of x plus 20. So just analyze what it is that you are changing in these questions to get them to be the same. Okay, so what do I have now? I have the sine of, where am I now? I'm now going to combine them using my formula cos, cos, sine, sine. Now remember, I changed this thing over here. I was in a quadrant where my sine was negative. Okay, so that negative had to make this negative a positive. So the sign changed over here. Again, look at that, 180 plus x plus the 65. Okay, folks, so if I change this sign, which was negative because this resulted into a negative, then I get the cosine of the first angle, x plus 65 here, That's a plus, so I minus the second angle, x minus 20. Remember, if there's a negative in front of the angle, like this says, if this is now a plus, let's change this to a plus, then this becomes a minus. If this was a minus, this remains a plus. So we're ready to conclude our answer. The cosine of x minus x is gone. We've got 65 minus 20, and that leaves me with the cosine of 45 degrees, and without a calculator, that is 1 over root 2, or some of us uses root 2 over 2. Okay, so what was the takeaway in this particular question, folks? You had angles. You first of all had an arrangement of cos and sine. The cos, cos, sine, sine cues to you that this is a compound angle. You don't want to change those ratios at all. Okay, you want to leave them the same. So we zoom in on the angles. We saw there was an x plus 20 and an x plus 20. Then there was an x plus 65 and an x plus 245. We had to take that x plus 245 and we had to reduce it to an angle that we resemble with a 65. And immediately we saw it's 180 plus the 65. Okay, which immediately then told us that that is going to be minus the sine of x plus the 65. It changed the sign of the compound angle, which meant instead of adding these two, we had to subtract them from one another. They became a special angle, and we had our answer.